The death of a star is a dramatic and transformative process that depends on the star's mass. Stars go through various stages of evolution during their lifetimes, and their ultimate fate is determined by their mass. Low to medium mass stars, like our Sun. Main sequence. Stars spend most of their lives in the main sequence phase, where they fuse hydrogen into helium in their cores. This phase can last billions of years. Red giant. As the hydrogen in the core is depleted, the star expands and becomes a red giant. During this phase, helium fusion occurs in a shell around the core. Helium fusion. Helium fusion generates heavier elements like carbon and oxygen in the core. This process continues until the core runs out of helium to fuse. Planetary nebula. In the final stages of a low to medium mass star's life, it expels its outer layers into space, creating a colorful cloud of gas and dust called a planetary nebula. White dwarf. What remains of the star's core after the planetary nebula phase is a dense, Earth-sized object known as a white dwarf. White dwarfs slowly cool and fade away over billions of years, eventually becoming cold and dark. High-mass stars. Main sequence. High-mass stars also begin as main sequence stars, but they burn through their nuclear fuel much more rapidly. Supernova. When high-mass stars run out of nuclear fuel in their cores, they undergo a catastrophic explosion called a supernova. During this explosion, they can briefly outshine an entire galaxy. Neutron star or black hole. The core of a massive star collapses under the force of gravity. Depending on its mass, it can become a neutron star or collapse further to become a black hole. Neutron stars are incredibly dense and spin rapidly, emitting beams of radiation visible as pulsars. Black holes have gravitational fields so strong that nothing, not even light, can escape from them. The death of a star is a fundamental process in the universe, as it is responsible for creating and dispersing heavy elements into space, which can later form new stars, planets, and even life. Supernovae, in particular, are critical for seeding the universe with heavy elements beyond helium. The specific path a star follows in its evolution and death is determined primarily by its mass. Low to medium mass stars like our Sun end their lives as white dwarfs, while high mass stars end in spectacular supernova explosions, often leaving behind exotic remnants like neutron stars and black holes. These events are essential for the evolution of galaxies and the composition of the cosmos.